Morning. I'm Gary Eek from Cisco's healthcare team. Welcome to this morning's session. Hope you had a lovely gala dinner last night and not too many late drinks in the bar. It's with pleasure that I introduce Dr. Stephen Tucker from Tucker Medical in Singapore. Dr. Stephen Tucker trained in internal medicine, hematology, oncology, and stem cell transplantation at the UCLA Center for Health Sciences. While at UCLA, he studied molecular biology in the laboratory of Dr. Charles Sawyers and joined the UCLA faculty as assistant professor of clinical medicine in 1999. In 2006, he moved to Singapore to develop a global oncology clinical trials program and has made Singapore his permanent home. And it's with pleasure from Singapore, connected via the NVI network and Cisco telepresence, Dr. Stephen Tucker to talk on From Qualified Self to Quantified Health. Stephen, over to you.
Thank you very much. Can everyone hear me okay? This is a new experience for us. Sounds good? All right, I'll keep moving ahead. Thank you for the introduction. The introduction is a little overwhelming. I don't quite think of myself as the oncologist from UCLA so much anymore. I'm also the global health advisor for Singtel, Singapore Telecommunications, and I'm fairly passionate about quantified health and digital health, mobile health, and I want to sort of take you through some of the tools and the ideas in quantified self that have led to what are important, if not fundamental, changes in the way we're going to view healthcare and not necessarily medical care in the future. With that, let me start by telling you that you can't understand the problems today without looking at the scope of disease and how we got here. So I'm a big believer that this is not rocket science. I know a lot of people smarter than me, worked harder than me, and it's all because they're good communicators. Communication is what's critical. So clearly, we have aging populations, whether it's in the US or here in Singapore or the EU. Aging populations are going to dominate healthcare. We have more and more people over the age of 85 as time marches forward. We get chronic illnesses as we age, at least currently. These chronic illnesses are no surprise to anyone in healthcare or medical care: heart disease, diabetes, cancer, etc. And we spend far more money on chronic disease than we do on any other part of healthcare. Specifically, in the U.S., we spend nearly 85% of an almost $3 trillion budget on chronic illness. If you have a chronic disease, one chronic disease, you're in column number 1. But if you add up columns 2, 3, 4, and 5, people who have more than one chronic disease, they exceed those with just a single disease. People have multiple problems. How did they get these problems? Personal behavior. Sounds like from what my host said, it's what you did last night. A little too much drinking, a little too much eating, maybe a little bit of smoking. But personal behavior is responsible for the vast majority of the risk factors that lead to chronic disease. Let's make that easy to read. This is the number of people, at least in the US, who smoke. The percent who are defined as inactive, sedentary. Those people with high blood pressure, those people with high cholesterol, diabetes and pre-diabetes. If you haven't been tested for pre-diabetes, after I'm done talking, go out and get tested. Most people who have pre-diabetes have no idea. And of course, obesity and overweight, which is driving most of these problems as well. If we don't do something about obesity, it is going to be a nearly $1 trillion cost by the year 2030. But enough of, what are the risk factors and what are the diseases? Let's make this simple. Let's go straight forward. How do people die? Well, the red and the blue are heart attack, stroke, and cancer. 7 out of 10 adults are dying from heart attack, stroke, and cancer, and it's vastly, at least with cancer, 70% is preventable. Throw in a little bit of Alzheimer's, lung disease, homicide, suicide, kidney problems, and that's how people die. Whether it's in the EU, the United States, Australia, or any developed or economically stable country, that's how people die from non-communicable diseases, NCDs. Well, that's the sad part of my talk. It gets better from here. Let's talk about tracking. How did we get here? If you've got an MBA or went to business school or studied economics, this sentence makes sense to you. But we don't do this a whole lot in medicine. All these other industries measure data. You look at your financials, you look at your month-on-month returns, you look at your own retirement account. But how do doctors measure their success in a single individual practice? Well, honestly, they don't. There's no metric that we're using. But doctors do have one metric, and that's vital signs. This is the dashboard we've been using forever. And we know that you have to measure vital signs. It's something that the doctors are comfortable with. So what happens when you start having access to more and more data that's legitimate? But let's talk about the tracking. Most adults are tracking something. 7 out of 10 adults are tracking a single, or at least one health indicator. And in fact, those people who track, almost 50% of them, tracking changes their approach to health. It gives you a feedback loop. And in fact, many people say that tracking affects how they're going to treat disease. That is, self-treat or seek medical care. If you're rigorous about your tracking, you get better data. And guess who's rigorous about tracking? People with chronic disease. That's the connection here. If you've got high blood pressure, if you've got diabetes, you're already tracking. You're part of the quantified self. I see you guys. I know you see me, but can I see a show of hands if you've heard of quantified self? Anyone? I see, all 20 of you. Thank you. Okay. People are there. This is cool. What is quantified self? Quantified self is self-tracking. It's helping people get information out of their personal data. It's thinking about you as the subject matter expert. Quantified self, this is actually an old slide I should update. There are over 40,000 members globally in Quantified Self, and they're in numerous countries on every continent. No surprise, I co-organized Quantified Self here in Singapore. And Quantified Self, why did it happen? Well, because we have these powerful computer chips that get better and better and cheaper, that all of you have at least one supercomputer in your pocket disguised as a common telephone, because it suddenly became cool to share vast bits of information about our lives across the internet, and we have unlimited data storage in the cloud. That enables quantified self. And again, quantified self, it lets your data be applied to you. It's personal information, and we help people make sense of that information, not against the mean, not as an average, but for you. That's what's important in QS. Additionally, QS is peer-to-peer. It's people helping people, not doctors helping people, okay? P2P, patient to patient, is the future of healthcare, not doctor to patient. And so if you get sick, if you have diarrhea, who are you going to tell first? Family and friends, spouse, okay? Who knows second? Google. Google knows when you're sick. Google knows when you're pregnant. I'm the third person to know. The doctor's the last person to know. Now, this is actually the really fun part of the talk. Let me show you the tools. What is enabling quantified self and quantified health going forward? And first, where do we measure? What to measure? You can measure steps, for example, activity. That's what this shows. You can measure sleep, also known as inactivity. You can measure things like glucose. But increasingly, I can measure where you've been, what you've done, perspiration, and add layers and layers of information to these timelines. Where to measure? Anywhere on the body is the takeaway. You can measure on the wrist or the hands, the ankles, your ears, all sorts of places. How do we measure? These are screenshots from my own iPhone, and there are sensors in your phone. You can measure the linear acceleration, the gravity, the magnets, everything in the phone. And if you download, for example, an app called Sensor Kinetics, you can see live what it's like when you take a step forward or side by side. Why is that important? Because when I do a live example and I show you that you're moving forward like this, that's a normal step. But if you have Parkinson's disease, you move like this, and that's captured in your phone. And I'll be able to take a simple phone and interrogate it and tell you that your parent is developing Parkinson's, that they have an abnormal gait. When to measure. 2 points here. Intermittently, what's my blood glucose at this moment? Or continuously, what does my continuous glucose monitor tell me? Every 1 minute, what is my blood sugar? What is my blood sugar when I wake? What is my blood sugar when I speak? What is it when I eat a banana cream pie or have a sip of scotch? And now, how to measure. Well, I bet half of you at least have some kind of device with you, purchased or in your sock drawer, that measures the number of steps you take. So the lowly Fitbit is the leader in this pack, a simple pedometer. And as you know, it's an ecosystem at this point. And that ecosystem got expanded. This slide's actually a year old. I said a year ago Christmas, the big boys got into the game with the Polars and Garmins and LG and Sony. Why no one ever hooked the LG wristband to the LG refrigerator, I'm not sure. Because in my future, if I don't do 10,000 steps a day, I'm not going to let the refrigerator unlock. And you think that's a joke, but wait till we see where this goes. What about a smartwatch? Well, these were the first smartwatches, and then there are more watches. These are watches that can measure perspiration and GPS and fine measures of your sleep that can possibly even diagnose sleep apnea. And then watches that bring the two together, that bring fashion and fitness and the technology of a smartwatch all in one. All of these devices available today. But moving beyond the watches, okay, moving beyond a wearable, let's talk about medical consumer devices that measure sleep. So most of these devices are casting out some kind of ultrasound beam that measure my chest movements and honestly are capable of diagnosing sleep apnea. What about measuring my brain? These are all single or multiple lead commercial grade EEG, electroencephalogram. They can measure my concentration. They can measure my meditation, relaxation. I can measure them. It Bluetooths back to my phone. It Bluetooths to my computer. I can play computer games by wearing these. I can control the size of a virtual fire. I can fire virtual darts by concentrating or relaxing. It's a primitive brain-computer interface. Keep in mind that if I can talk to my computer through my brain, ultimately my computer can talk back to me. And you want to think about what that means to have a computer virus when you put a brain-computer face on. It sounds ridiculous, I know, but this is where we're headed. How about simple things? Blood pressure, oxygen level, body fat. Everybody's seen these devices. But what about devices to measure your posture, to remind me to sit up straight, to remind me where I lost my luggage? What about devices in my feet as the sensors go down in price? How well did I kick a soccer ball? How much force is in my ankle when I'm dancing? That's what these measure. How about a helmet? The bicycle helmet and the baseball cap both measure heart rate. The baseball cap also measures if I get sleepy. Who's been driving a car and done this, if you can see me well? Right? That's called microsleep. 250,000 accidents in North America every year from microsleep. But if I use that same accelerometer in my phone, put in that baseball cap, I know when I do that jerking motion and it wakes me up. Most Mercedes, high-end Mercedes, have the same technology built in today. The black cap labeled Reebok, it measures the force of a hit for a boy playing American football. And all of these devices are concussion measurements. Every time one of these American high school kids gets tackled, and even if he pops up and he waves to the grandstand, says, "Mom, I'm okay," Mom's going to look at her phone and say, "That was a really hard hit. You're going to start playing soccer. No more of this football." But why would you even buy a device? Can't I just put it in my clothes? Are there fabrics? And the answer is yes. Absolutely yes. Can you name the 4 of the biggest, most widely available technology companies today? I can. Nike, Adidas, Under Armour, and Reebok. And they're all making clothing that are going to measure where you go and what you do. You're going to buy Gap or Uniqlo or H&M, and you're going to buy T-shirt or T-shirt Plus. And that T-shirt Plus will handle 20 washes and measure continuous heart rate. That's the future that's coming in quantified self. I can put these in my ear and measure GPS and heart rate as well. I always put that little one in the right bottom corner. It's a cochlear implant. I'm all for a bionic ear. Those get smaller and smaller every year. How about devices, personal devices to measure toxicity? Most of these are measuring UV exposure, and melanoma is one of the fastest growing cancers in the world. So we would want to know how much ultraviolet light we're exposed to. The fancy one in the left bottom corner measures the exposure to dangerous particles in the air. So I live in Asia. Every time I go to Beijing, the 2.5 size particles, those are the ones that get past the mask. Those are the ones that cause asthma and lung disease, and that device measures it. These are quantified cups. To save time, I'll go past that. That's a long story. I like these devices. These all measure blood alcohol. The one front and center in blue, it's also hooked to Uber. If I blow into that device too strongly, it can call Uber for me and get me a ride home so I don't drink and drive. These are all do-it-yourself laboratory tests becoming widely available. The one in the center will be with us first from a company called Scanadu. It's a standard urine dipstick hooked to an app that's quantified against the colorimetric system that'll reflex to an antibiotic, and you'll buy that in a vending machine. The object in the upper right is called Q, C-U-E. That's an at-home test. There are 5 different kits: vitamin D, influenza, a HCG for pregnancy, testosterone for men, and CRP for inflammation. It Bluetooths to your phone. You could buy a dozen of those for less than $100. These other ones are all participants in the Nokia Sensing X Prize competition. Women's health. That's the second largest market. I'll tell you the largest one in my personal opinion in a minute, but this is one of many fertility devices to see what is the accurate temperature and the right time to get pregnant. Look at this. I've got 3 different temperature sensors, one for fertility. The one with the dangerous looking probe is for monitoring pregnancy. The other 2 devices that look like they're made out of soft rubber, well, any woman who's had a baby and is worried about incontinence has been advised to do Kegel exercises, pelvic floor muscle contractures. Both of those devices measure the strength of the Kegel exercise. As ridiculous as that sounds, I'm showing you 2 competing brands. So that is a real market when there's competition for Kegels. The quantified baby. The quantified baby is the biggest and scariest market. We already know that new parents are absolutely frightened of, doing something wrong. And having more data seems like a good idea, but it will make you paranoid. But these kinds of sensors, the quantified baby is real. And I can't remember. Let me look here. Yeah, I put all of these in the deck. There are at least 5 or 6 different companies trying to quantify how many times Junior's going to roll over in the crib. You thought that monitor that allowed you to hear and see the baby was enough. That's no good without knowing the temperature in the room and the temperature of the baby and how many times little baby is breathing per minute. And you might think you're not going to do it, but someone's going to give it to you as a gift. And then you're going to find an opportunity to use it, and you're going to be the quantified parent. I'm taking you on a trip that went from a Fitbit and now is migrating into medicine. This is diabetes. They were the original quantified self. In the top right corner, you have a Medtronic continuous glucose monitor. In the middle, you have Google/Novartis glucose sensing contact lens. You have Dexcom's G4 state-of-the-art continuous glucose monitor, or the iHealth glucose monitor, which is available in the Apple Store. Dexcom, I believe, also, Abbott makes the little one in the bottom right corner, and Dexcom just announced yesterday, I turned in my slides over a week ago, but yesterday Dexcom announced that they're going to get rid of that big black box with the graph that says 90, because now Dexcom's going to go directly to the Apple Watch. Yeah, that's how fast this is moving. How about a Bluetooth-enabled EpiPen? Wouldn't you want to know if your son who had a peanut allergy had to use the EpiPen? Welcome to my world. How about an asthma device, a metered dose inhaler that's got a Fitbit equivalent on the top, Bluetooths to your phone, and tells you where and when you need your asthma medication to now crowdsource pollution and see that the air quality in one part of the city is different than another part. A device here for PMI 2.5, a device that measures nitrous oxide, and a device that measures how well you inhale your inhaler. How about a device that measures the blood flow through the coronary arteries? This is medical grade. You can't go buy this yet without being a physician, but it's available today. The stethoscope. My friend Eric Topol talks about the stethoscope being the very best technology available 220 years ago, right? Well, the stethoscope is nothing more than a Typhoid Mary with 2 plastic tubes spreading germ from room to room, in my opinion. These are all cardiac monitors available today. You can wear them for anywhere from 3 to 14 days. They do continuous heart rate monitoring. They can be consumer grade or professional grade, and they can do everything an advanced Fitbit can do on top of measuring your heart rate. And this is a boon for pharma. This is great because now phase 1 and phase 2 drug testing, we can now see heart rhythm changes that we would have never captured before. Behaviors, sleep, tossing and turning at night that you would have never seen in drug development. And I'll end on this part of the talk with, again, medical grade stuff, but come on, we can swallow tiny little cameras that can film our bowels, our intestines, and look for celiac disease and gluten intolerance and parasites quite easily today. Moving on to ultrasounds, handheld ultrasounds, replacing the stethoscope. It's pretty ridiculous. It sounds science fiction, I know. And I do get kind of excited because I like science fiction. And if you don't know, this is the Star Trek tricorder. It was supposed to be able to diagnose and treat all at once, wave it over the body, and it would fix the sick alien or Captain Kirk, as the case may be. But this is a real tricorder. This is made by a company called Scanadu. It's called the Scanadu Scout, and it's supposed to measure heart rate. It's supposed to measure blood pressure just by holding it to the surface of your forehead. Well, I got news for you. This is a live, working Scanadu Scout. It measures my blood pressure, my heart rate, my oxygen level. It measures all of these things at once in a 15-second scan. And when you go back to my photo of the GE Dynamap blood pressure device in the very early slides, that's data that a doctor can use. That's data that a doctor cannot refuse from an anxious mother who says, I've been checking little Johnny's heart rate, blood pressure, and fever every morning before school, and today it looks different. Or my computer tells me the predictive analytics have said he probably has the flu. What do you think, Doc? That's the way it's going. And this medical tricorder is no joke. I mean, I'm part of the clinical trial. We're going for FDA approval. The company is, to say accurately. They're not the only one. There is multiple companies with their own versions of tricorders that can measure all of those items. The one in the top left is a cushion that you sit on in your chair that does all of that information. Like I said, it's kind of ridiculous. It's like I'm selling you a flying car. But that's a real flying car, and these are real devices. I don't even think you're going to buy these devices in 5 years. You're going to have a temporary tattoo made of silicone that you're going to wear, that you're going to put on your children or your father or your sick parent. And as ridiculous as that sounds, that's a real device from a real company in Boston. It can do heart rate. It can do temperature. It can do mobility and Bluetooth it to your phone. It's a beautiful silicone temporary tattoo. And yes, you will put it on your baby the first weekend after you're going to leave the kids alone and get some vacation and your in-laws come to stay. That's the first time you're going to put the tattoo on the baby, no doubt. What does all of this information do? This information helps you view your health in a completely different yet logical way. Begin to think about your health the way Google creates a map. This is called a Geographical Information System, a GIS. And a GIS is intuitive to engineers, and a GIS is how you make a map. But in this case, I've labeled this as a map with sleep and activity and environmental exposures and blood and urine to make you a unique individual. But in other talks and on a different day, I could substitute these words with genome and microbiome, exposome, proteome, epigenome, and phenome. I could also substitute it with your activity data, your consumer spending data, your GPS from your car, and your interactions on Facebook. And I smash all that data together, not to look at the average, but to look at the unique individual that is you. Why? Because we are in a pivot. We are not going to have a pivot. We are in the middle of moving from a reactive medical care system to a proactive wellness-based system. That's the future of health, not the future of medicine. Crashing your car is a foolish mistake. Son, why did you crash your car? Didn't you know better? Well, we're going to start to look at health that way. And we're going to start to look at personal behavior that way. And that's the future of health. So I'm getting near the end, but I like to sort of joke that, all right, I'm the quantified self doctor and the data health guy. And what am I going to do? I'm going to go home at the end of the day after doing all my quantified stuff. But I don't go to a standard home, and this is what homes often, private homes in Singapore might look like. I go home to the smart home. Okay? I go home to a home that is the Internet of Things. So, ironically, this is a slide from Cisco, and I didn't know that I was going to be in the Cisco offices to present today, so it is not meant to be a plug, but it deserves to be a plug for Cisco, because Cisco's had this slide for over 3 years. I've used this slide for a long time, because it's very important to understand that the blue circle on the left represents all the people on Earth in 2003. And that blue circle doesn't change very much by 2020. But the orange circle represents all of the devices on the internet over time. And so quickly, the number of people is dwarfed by the number of things on the internet. What are those things? Well, how about your home thermostat and your home camera and your home fire detector, smoke alarm? What about the light bulbs you buy from a variety of vendors that automatically turn on when your favorite music comes on, the lighting changes? Or when I get close to home, I trigger a GPS alarm that says I'm a mile away from home and my thermostat gets turned up. How about the bed that is on the internet so that I can actually see whether 1 or 2 people are sleeping in that bed, where I can measure if little Johnny is in bed when he says he's supposed to be in bed? How about a smart lock? You go to my house, I'll unlock it from here, okay? Just like Find My iPad. Or how about a smart battery? Not a smart smoke alarm, but a smart battery that tells the internet when it's time to be changed. And of course, home security cameras. And then, things like this. This is a company called Quirky. GE, I believe, owns all of this. And if you look at that power cable on the top right, each one of those extension spots is on the internet. Imagine being able to turn on and off your power cord from your tablet while you're listening to me. So the Internet of Things is going to be 50 billion devices and a massive, medical device revenue. And you're going to go from being, think about it. You have an iPad, you have a phone, maybe you have 2 phones, maybe you have a Fitbit. Maybe you're me and you have 20 devices and you're like a glowing smart thing wherever you move on the internet. We will have more and more devices per person. This is a sort of a pie graph of what is the Internet of Things, the devices, the software, the infrastructure. I'm only talking to you about if this were a clock, from 10 p.m. to 12 p.m., the wearables, the watches, the vitals, the textiles, the glasses. That's the Internet of not things, but as I call it, and many others, the Internet of caring things. So what is this Internet of Things? To me, it's data. Data gives you information. Information leads to insight, and we turn insight into action. That's why we're not going to be going to the doctor for illness. You're going to be going to your smartphone and your health advocate for wellness. So this is also a map of the Internet of Things. And it might be hard at the distance where you guys are to see that in 1992, there were 1 million devices on the internet. And moving forward, where the whole idea of IoT comes up, I think it's about 2008. And there's, at that point, maybe 9 billion devices on the internet. And even today, in 2014, we're 20, billion devices on the internet. But when I look at this map, with this chart, you know what I think? I want to give you some relevant timeline to this. That was the phone that was available in 1992. And then these are the phones that we've all used in the last 20 years. So keep in mind that I have right here on my wrist, or the device I'm showing you, state-of-the-art wearable technology. And this stuff is the equivalent of that cell phone on the far left. Try to imagine just 10 years ahead to the first iPhone of wearable technology and ask yourself how that changes healthcare and medical care, and remind yourself what's the difference between the two. Our bodies generate an enormous amount of data every day, and we're only beginning to tap into that data stream. Thank you. I hope this worked out for you guys. It was easy for me. It looks like we still have some time for questions.
Thank you, Stephen. Very enlightening presentation. It certainly shows the pace of innovation. We do have questions. We have a mic in the audience if you want to raise your hand.
Hi, thank you for that. That was excellent. I'm just wondering, with the new, with all this data available, do you think that could feed into people's anxieties that are almost looking for a reason to be ill?
Yes. No, absolutely. And I practice medicine every day, and I view this entire ecosystem, whether it's genetics or wearable technology or Internet of Things. I often say, I describe myself as, about wearable tech, genomics and precision medicine, and patient engagement and empowerment. What I follow with is the ability to be empowered and engaged is not a mandate to be engaged. And understanding who's a hypochondriac and should not Google headache, and who wants to Google headache appropriately, is still what's important in being not just a doctor, but someone involved in health and medicine. But you could have the same concerns for looking at a retirement account. You could have a lot of concerns about anxiety. But I think that my personal opinion is more information is better information. And when I talk about DNA, for example, I have a slide around DNA. It says, it shows a piece of paper like a test. Somebody said, when you hear genetic counseling, what do you think of? and the student has written in pen, bad news, right? If you hear genetic testing, nobody thinks, cool, that's good news. But the reality is, your DNA, like your medical data of any kind, is not your destiny. It's your potential. And so the more we can educate people about the potential for their data, I think the better we're doing as a educator.
Thank you.
Thank you. Very fascinating talk. Now, I am a medic as well. I was wondering now, IT software monitoring is developing very fast. Where would we stand in a medical curriculum about introducing these very early? Thank you.
Medical curriculum is one of the single biggest impediments to moving healthcare forward. Medical curriculum, like all curriculum, is in a crisis point of disruption. We don't know how to move fast enough. I mean, we don't have enough teachers to explain this. If you graduated medical school before 2001, that was before the Human Genome Project concluded. And so this is a huge challenge to which I personally do not have an answer. There are many ideas about reforming medical curriculum. And when I think about it, one of the things that does come up to me is the difference between being a surgeon and anyone else. Because I think that surgery has the potential to go the route of being a drone pilot. That you could be a tele-robotic surgeon operating in a dark room, promising to do 6 gallbladder operations a day and keeping score with currently someone on standby in case it goes wrong. But you could have a place like Singapore doing 10,000 surgeries a month in places all around the world. So I think that the physical skills and IT are one pathway, but the emotional skills and the knowledge skills are very different. Medicine used to be a knowledge-specific domain, and you could only get the knowledge by going to school. Now we all have the knowledge because we have a smartphone. Vinod Khosla, founder of Sun Microsystems, likes to poke at doctors and say that 80% of what doctors do can be replaced by technology. What he means by that statement is not that 80% of doctors should be replaced by technology, but that typing into a medical record or me getting on the phone with an insurance company is not a good use of my education or time. And I think that teaching people, doctors, professors, and students, and patients, that technology will allow doctors to spend more time with people and reestablish therapeutic relationships while getting past some of the physical requirements that we no longer need to do. So that's a message that has to be taught, but nobody ever looked to medicine for, revolutionary reform. We are a very conservative infrastructure.
Any more questions? We don't have any more sessions in this room till just gone 11 o'clock. But I think that's all, Stephen. So thank you very much for joining us from Singapore and taking time out of your busy schedule. Much appreciated joining us here at the Digital Health Assembly. So thanks again.
All right.
Enjoy the rest of your evening.